much
The
less
Inception thing.
booming. Okay, here we are. It's hello everybody. It's 3:05, and I want to welcome Milecia McGregor, who is going to talk to us about using reproducible experiments to create better models. As someone who's taught research methods for many years, I am very interested in this talk, so I feel fortunate to have been selected to host it. Robbie and I are going to become less visible, but we'll still be here, and there'll be a question and answer in the last 10 minutes. So on that, let me tell you a little bit about Milecia. She is the developer advocate at Iterative.ai, and the main business of Iterative AI is metrics-driven processing using data and code. So on that note, we're going to go into the background, and you can take it away, Milecia.
All right, sounds good. So, hey everybody, my name's Milecia, and like she mentioned, I'm a developer advocate at Iterative.ai, but I mainly work with our open source tool, DVC, which is this data version control CLI tool. So we'll be getting into that a little bit today, but just a really quick background on me. I have my master's in mechanical and aerospace engineering. Then I worked with robots for a little bit, which is where I got my experience with machine learning. And then I jumped off into WordPress for some reason. And I ended up doing front end, back end development, DevOps, blockchain, pretty much everything else tech related. So this is why I'm excited about telling y'all about reproducibility today, because a lot of stuff, once you've done it, you can't do it again. But I'm going to show you some cool things about that. So to get started, I always like to give a quick overview of what I'll be talking about, just so, well, you know what to expect, so you don't miss anything. So first, we'll talk about a little background on tuning hyperparameters and why that's so important. Then we'll talk a little bit about using DVC itself. And then we'll get into a couple of methods for hyperparameter tuning. We'll start out with grid search first, then we'll talk about random search, and both of these will have live demos. So I checked that everything was working about 10-15 minutes ago, and it was fine. So hopefully nothing weird happened during that time. But after those live demos, I'll wrap up with a few key takeaways, just a couple main points that I hope you get out of today. So first, some background on tuning hyperparameters. It might help to know what a hyperparameter is if you don't already, but basically a hyperparameter is one of the parameters that define your model. So if you're working with a neural net, the number of hidden layers in that neural net, that would be a hyperparameter. Or if you're working with a random forest classifier, maybe the max depth, the learning rate, maybe a batch size or something, those would be hyperparameters. But basically, the hyperparameters are what make your model. So the process for part of the process for searching for the ideal model is called hyperparameter tuning. This is where you go through this iterative process of checking different hyperparameter values and seeing how they affect the overall results that your model produce. So basically, you're plugging in some random numbers and seeing if they throw out good numbers or bad numbers. But one really important thing to note is that hyperparameters cannot be trained from your data, which is unfortunate, but we can't do it that way because we're using the hyperparameters to make the model that we train with the data. So we can't get the parameters for the model from training if we don't have values to plug into the model, if that makes sense. So basically, you can't make the model from the data, but you can check how well the model is performing with the data. So as you go through the hyperparameter tuning process, you'll probably also be running training and validation scripts, maybe not validation, depends on the project and your process, but you'll at least be running the training process for these hyperparameter values. And you'll be able to see how your accuracy, your loss, your training time, all these different key metrics, you'll see how those change as you play around with those different values. So now a little background on DVC and why I'm even bothering to talk about it today. One thing that is extremely tedious to do with a data science or a machine learning project is to keep up with all of the little changes that you make to get this great model that you deploy to prod. But a lot of times in a common flow, it starts with you have this Git repo and you're making little code changes. Maybe you want to try a different model on your data set, or maybe you want to add another layer to your hidden model or something like that. It's just something within your code that changes. So you'll have a lot of different Git commits for this, and they'll all have these tiny, tiny changes. And then you have to hope that you don't start writing the same Git commit message over and over again. Not like that's happened, but it gets to that point where you don't know what else to say about changing the same thing again. And another part of that is the actual hyperparameters. So a lot of times those values are tucked away in some config file that might be really hard to read, putting it nicely. And it might start executing steps in your machine learning process that you really didn't need to do again. Like it might start fetching data again because you changed one hyperparameter. So now the whole pipeline has to run from the beginning, and you're stuck sitting there waiting for it to finish just from one change. So yeah, that's another thing that you have to keep track of, those hyperparameter changes. And then don't get started with data changes. Maybe you get more data to add to your training set, or you find out some of the data you have isn't that good, so you need to remove some files, and you have to package all of this together with your code changes, your hyperparameter values, making sure you have the right version of data all for one experiment. That's a lot to keep up with. That's using a lot of different tools. I've seen people just commit zip files of their data, and that it doesn't work. It just doesn't work that well. So that's where something like DVC comes in. It makes all of this experimentation reproducible, whether it's hyperparameter tuning, code changes, data changes, whatever. Any experiment that you run on your model can be reproduced. Like end to end, you don't even have to have zip files for your data. Everything is versioned and tracked for you. And the cool part is you don't even have to add anything to your code. Like you install this little tool in your repo, and it starts collecting this metadata that it stores in Git, and you're done. Everything is tracked for you, and you didn't have to add a single line of code to any part of your machine and learning script or part of the process, anything. You just install a tool and it's good to go. So now I'm done talking about DVC. Let's get into grid search. This is one of the common methods used for hyperparameter tuning. And basically what it does, let's say you are working with a random forest classifier and you have a learning rate, a batch size, maybe you have some kind of max depth. That's three hyperparameters, right? Each of those hyperparameters could have a range of 20 to 100 different values to cycle through. So when you're doing a grid search, it does an exhaustive search over every combination of values available, which is great if you have the time, you have the resources and you can wait for it to check through everything. Maybe you're working on some really sensitive project, like you're taking images of cancer cells and trying to determine whether it's positive or negative, or you're working with some kind of genetic data where you're trying to determine if someone has something wrong with their genetics. I don't know. These are things that you might want to spend that extra time and those resources on to find the absolute best model possible. Because with grid search, as long as you give it a reasonable range of values, it will eventually find the most optimum model that you can get. It just takes a lot of time to go through all of those values because you're running the training script, and however long it takes to train, that's how many, training time multiplied by the number of combinations of hyperparameter values is how long it's going to take grid search to go. But I do want to show you a way that you can kind of set it and forget it and go about and do other important things. Well, let me make sure I have the right thing open and make this a little bit bigger for y'all. Okay, so what you're looking at here is just a little demo project I set up. It's a machine learning problem that really isn't that important or that interesting, but it gets the point across because it's just an MNIST thing. I'm pretty sure everybody's seen the MNIST data set at some point. But what this is just a random classifier, and we are working with these two hyperparameters in particular, the N estimators, number of estimators, and the min number of samples we'll split. So we have these two hyperparameter values that we're going to experiment with. And if you come up here, you'll notice we're reading those hyperparameter values from this params.yaml file. So I want to take you in there real quick, because this is where some of like the special DVC magic starts. You'll notice we have three different sections for hyperparameters for different stages. So I want to point out what that is. This repo already has DVC installed, it's tracking. If you were interested, this .dvc folder has all of the configs that you need, and that's where this DVC YAML comes in. So DVC is an MLOps tool that helps you with your, machine learning pipelines. So you can make your pipeline in this YAML with these different stages. So here we have the prepare stage where we get our data, then we come and do some featurization to that data, then we finally train, and then we do some evaluations based on the metrics we get from our training stage. So if you notice, we see these same params here in this train stage that we saw here in this params YAML that we actually saw in our script. So that's how everything connects with DVC. And with the params being broken out like this in a modular way, if I change the hyperparameters for just this train stage, only the train and evaluate stages will execute. It will not go back and get the data and featurize it again just from one change. So I don't know about you, but it made me really happy when I found out don't have to do that anymore. But we'll be focusing mainly on this train and evaluate stage. I just wanted to make sure that you saw where the hyperparameters actually come in first. So up here, you'll notice that this train script gets executed when we get to that stage. It outputs our model weights, and then we evaluate how well the model performed based on these three metrics files. So we hold the scores, which will be the accuracy and the loss for each experiment. And then we have more specific things to this problem, like the PRC, and we have a ROC curve that we also look at. But now it's time to talk about grid search finally. So grid search is actually pretty easy to implement, at least with DVC. So this is a very small set of hyperparameter values, but I don't want you to have to sit here and watch me run experiments all day. And actually, I'm going to go ahead and execute this script because sometimes it takes a while. So we're going to execute this grid search. And what it's doing now is queuing up some experiments. So with DVC, you see here, we're using iter-tools to iterate over all of the combinations of these values. And then we're running this DVC exp run queue script with these different hyperparameter values here. So let me show you what this looks like in the table first. And I'm going to show you the clean table from the start, just so you can see the important things. Basically, I'm just getting rid of the timestamp, and I'm only going to include the params that we're actually updating. Okay, so this table shows you all of the experiments that we have in our queue. And that's exactly what we expect. Those are the values and the combinations we expect. And all we have to do is run it now. So the cool thing about this is if you wanted to offload these experiments to the cloud somewhere, maybe you have an AWS service or an Azure service that you prefer to run your experiments in because they have GPUs or certain RAM sizes or whatever resources you need. You can do that with queued experiments. You can even execute these on different services. So it's just an option. I'm going to clear out my terminal so we can see again now. And then I'm going to execute all of those queued experiments. So while this is running, I kind of want to explain a little bit more about what's happening with this grid search. Basically, what we're doing while the screen is twitching is we are running this train script for every combination of these two values to see what our metrics will be. So just as a quick example, we're recording the average precision and the ROC AUC value. And these are the metrics that we'll use to determine if our hyperparameter values are good or not. So after these experiments finish running, we'll be able to compare metrics across those values and see which set of values gave us a better model, basically. So this is running more than 4 times. So I'm going to go ahead and stop it and clear out the terminal. And let's take a look at that table again. I'm just going to arrow up here. Oh, wait a second. Not sure why I didn't execute those experiments. And of course this happened after I checked everything. But it's fine, because even if they don't execute, we can still look at a few things. But something else, while we're seeing if this is actually going to execute or if it's my luck that the live demo is going to have issues, because why not? But a couple things we can check out here. So again, this is from an older experiment, but you can see the metrics here. You can see these curve values, and you can see more values from those experiments executing. But another cool thing, let me see if my browser's open. If we take a look at plots, this will show you what it looks like for a single experiment that's been executed. So you get these nice curves to show you how your metrics are changing with respect to each other. And you can change these around however you want. But these curves give you another way to look at your metrics and compare experiments for if you need to give a report to someone, or you need to justify why you think your model is the best or something else like that. And another thing, if I look here at the DVC plots, when you have multiple experiments, if you want to compare them with each other, you have the option of doing that based on their experiment ID. So these were pretty similar in every way, it seems like. Maybe this one did a little bit, I don't know. They're pretty similar, but this is just one of the ways you can look at metrics with DVC and compare stuff pretty quick across experiments. And I guess it finished. Maybe I had an old experiment somewhere that is just using the same values. Okay, whatever. I'm gonna ignore those queued down here. But up here, where we actually have values, you can see how you can compare which one of these did better. So they all did considerably about the same, but it looks like this top one did just a little bit better as far as average precision. Yeah. So you might want to take this set of hyperparameter values and then start changing something else. Like maybe you want to play with the data set you have and add more data to it and train again. You already know which hyperparameter values you want to use, so you can play with other parts of it, or you can share this experiment with someone and they'll be able to reproduce the exact same thing, which is, I don't know, it's pretty cool when you're working with the team. But now that you've seen what experiments look like, well, at least with grid search, let's talk about random search real quick. This is another method for hyperparameter tuning, but it takes a lot less time than a whole grid search because it just pops around and checks random combinations of values from your hyperparameter value set. And one really interesting thing is that if you run grid search and random search for about the same amount of time, random search will usually outperform grid search. And it's just because it checks a broader range of combinations in a lot shorter time frame. So where it would take grid search maybe 3 times as long to check that same combination of values, random search just hops around all over the place until it's done executing, basically. But this is probably the most common way just because it does take up less time, it can use less resources, and the model that you get will generally be better. So for things like maybe image classification or maybe fraud detection, things like that. Maybe something that's not as life and death and needs that sound certainty that this is the absolute best model we could get ever. Random search is great. And it's also a great starting point for those problems where you do need absolute certainty. So now that you got a little background on that, let's do a quick demo with a random search. So clear the terminal, and I'm gonna close the grid script and open up the random search script. And I'm gonna execute this for 4 experiments just to keep it in line with what we did with grid search. I'm going to actually give it the same range of values. So this whatever 203 blah blah, gonna paste that in here. So it's searching the same range of numbers. And I'm also gonna change the min split to match it as well, because why not? So it's gonna pick random numbers between the same ranges as grid search. And let's go ahead and run this script, and then we can compare and see which one actually gives us a better model. So all of the experiments are queued up. If I go here and look at the table, let's see which values it gave us. Looks like it gave us, well, these values, which are very, very random. Let's go ahead and execute the experiments. So we'll do dvc exp run, and we'll run all of them and kind of ponder on why the rest of my queues are still there, but it's fine anyways because we're getting our metrics back. But one thing I do want to kind of stress while these are running is that when you're working on a project, it doesn't really matter what the problem is. We all want to make the best model that we can. And when you're working on a team, it's a lot easier to collaborate when you can tell somebody, hey, if you just pull down this repo and run a few commands, you have the exact same environment that I did when I ran these experiments. That's hard to do when you're working with a lot of different moving parts. But when you can reproduce an experiment end to end, you have more freedom to play around with different values. You have more freedom to just try out different approaches because you know at any point, if you did find a model that was, pretty good, you can always go back and pick up training from that exact point. You don't have to wonder what you did to get those results. You don't have to ask someone or try to find somebody who may or may not work there anymore. You have everything you need from start to finish. And I'm not sure how y'all handle data versioning, but Git is not the greatest at working with those giant files. So having something that can actually keep track of all of those little details while you're doing the real hard work is so helpful because it just takes a lot of mental load off of your plate. But let's see how this is doing. Just going to interrupt that and see where we are on our table. So did it execute those? It executed one of them. I'm not sure why that happened, but that's more of a personal problem than something I'm going to try to debug here. But I do want to point out that even though this was just one random experiment, look how it did with respect to these others. So to get similar average precision, it looks like it took grid search 3 iterations to find that, and it took random search 1. So this is one of those cases where it's like, yeah, same amount of time, random search just does a little bit better. But that is how you do a random search. You just get your range of values, you pick random numbers from that range, and you see what your metrics are for your experiment. And you can compare them the different ways that I showed you by looking at the metrics directly. You can make plots, you can make comparison plots for the experiments. There's just a number of different ways you can see this data in order to make it make sense to anybody who needs to see that. But with that being said, I'm gonna try to switch back over here because it's about time to wrap up with some key takeaways though. But being able to tune your hyperparameters quickly will make you more efficient at producing better models because you already know the process. You get your hyperparameters for your model, you get a range of values for those hyperparameters, and you just iterate over them and see which version of your model weights gives you the best results for your data set. And that is hyperparameter tuning in a nutshell. And then using tools like DVC to help just with machine learning processes in general is just something that takes another load off of your plate, which honestly ties into my last thing quite a bit. Don't be afraid to try new tools. So, a lot of time as very technical people, we like to work on really hard problems. And doing data versioning is a really hard problem, but that's probably not the problem you're focused on. You have a real machine learning problem where you're trying to get a model to predict something basically. And data versioning, while important, is not going to solve that problem. So there's a bunch of tools made by teams dedicated to this hard stuff to where you can focus on the other hard stuff of actually getting models out to production. So don't be afraid to just use tools that are out there. You're not cheating, you're not taking a shortcut, you're just being really smart with your time. So that is all I have for you today. If you have any questions, I'll be here for the next 10 minutes, or you can hit me up on Twitter at Flipped Coding. And honestly, the best way, if you're interested in any of the machine learning stuff, just join the DVC Discord because this is what we do. We teach people about machine learning. But yeah, that is all I have for y'all today. I hope that it was good. I'm gonna stop sharing my screen in case y'all have questions.
You should be able to see the Q&A stream. If you can't, I can read the questions to you, but there should be a tab for that. So,
I see them.
okay.
Okay, so would random search be more effective for controlling bias in the model? It's been shown that some medical image detection reproduces that bias does creep in there. But I think random search helps control for that bias a little bit better than grid search. Is just if the physician is still the one picking out the values that we're using to train with, it's still going to have a little bit of that bias built in, just maybe not quite as much.
Let's see. There are actually several more. Can you see them all?
Oh yeah, is
yeah.
DBC widely used? Yeah, like it's been kind of crazy the demand that we've had to have courses for DBC, which we are working on, but we have users all over the world. We have them in academia, we have them across industries, we have them in startups, we have it in like well-established companies. DBC is kind of everywhere. And then let's see. An example of using DVC on a real life model. We did have somebody in one of our meetups recently share an experience they had. They're, I don't know, some kind of AI company that does deep learning for some kind of fintech problem, but they use DVC with AWS quite a bit. And what they work with is more in the cloud than locally, of course. So they'll use DVC in combination with one of our other tools, CML, to integrate um, running these experiments in their CI/CD pipeline. So they can deploy to different environments and test out this model before pushing it to production. So that's one of the ways it's helped them. And for every PR that they generate, there's metrics associated with it directly there in the PR. So they can look at the plots for how well an experiment did right there in GitHub or GitLab or whatever they're using. And we've also had somebody else, another company was using it in their Azure. I don't remember which service they were using, but they were using it for something in Azure. And the main feedback we get is just it makes it easy to deploy things to the cloud in a way that you just don't have to track as much stuff. But we're still working on a few different implementations of stuff just from their feedback because we're always adding new stuff to the tool. Like for deep learning, we've added checkpoints to log metrics for each training epoch. And that helps prevent overfitting and underfitting quite a bit. That's some of the feedback that we've gotten from some of the people that use DVC on real models. But I think those are those are the stories that I have right now for DVC on models in real life. And then tuning starts with values based on experiments. Yeah. So tuning does start with values based on experiments or just, what's the word? Heuristic values, something that's common, well, common knowledge around the industry, or they'll hire someone that has just spent a lot of time combing through data. Maybe they get somebody that does a lot of data labeling and they get some kind of range of values from them just because they've worked with a lot of different machine learning engineers, so they know what range of values things kind of fall in. But yeah, it just starts with some random values pretty much, and you see what works.
Try it out and find out the PG rated version of that. Anyway.
That is exactly it.
Yeah. Sometimes you gotta. Thank you so very much again for being here and for sharing the information. And the session is recorded, so it'll be available for a while for rewatching. I think we are coming up on a 15-minute break before the next sessions now, so take a load off virtually. And there's a feedback form in chat that will be appearing in the chat, courtesy of my colleague Robbie. Please take time to fill that out, attendees. Thank you again very much. Have a good rest of the weekend.
Yeah, have a good day.
Thanks
for having me.
Thank you.